In this section, we're going to look at solving equations with variables on both sides. The first example is 7k equals 4k plus 15. Again, we want to try and isolate the variable, so we want to bring terms that have the variable k to one side and terms without it to the other side. So in order to bring 4k to the left side, we have to subtract 4k on the right side. But if we subtract 4k on the right, we have to do the same to the left. So the left side, 7k minus 4k, now equals 3k. If we subtract 4k from the right side, the 4k's cancel out and become 0, so we're left with just a positive 15. We now see that we have 3k equals 15. In order to isolate the k, we have to divide both sides by 3. When we divide 3k by 3, we get 1k, and when we divide 15 by 3, we get 5. So we can see that k equals 5. And now another example of this. 5x minus 2 equals 3x plus 4. We want to start by moving the x's to the same side. So we're going to move 3x to the left side. In order to get rid of 3x on the right side, we have to subtract 3x. If we do subtract 3x on the right side, we must subtract 3x on the left. So 5x minus 3x equals 2x minus 2. If we subtract 3x from 3x, we get 0, so we're just left with a positive 4. Now we want to move the negative 2 over to the right side in order to have 2x by itself. So we must add 2 to both sides. 2x minus 2 plus 2 causes the negative 2 and the positive 2 to cancel out, leaving us with just 2x on the left side. 4 plus 2 equals 6. Now we have 2x equals 6. In order to get rid of the 2, we have to divide both sides by 2. When we divide 2x by 2, we are left with just 1x, and 6 divided by 2 equals 3. Now we're going to look at a problem that requires simplifying on each side before solving the equation. 2 parentheses y plus 6 close parentheses equals 3y. You can see that you have to start off with the distributive property first. You want to start by multiplying 2 times y plus 2 times 6. The 2 must be multiplied to all terms inside the parentheses. So you get 2y plus 12 equals 3y. Now we want to bring the y's to one side, so we're going to subtract 2y from both sides. The reason we subtract 2y is in order to cancel out the 2y on the left side. 2y minus 2y equals 0, so we're left with 12 equals 3 minus 2y, which is 1y. And because we only have 1y, y equals 12. We're now going to look at an example that may come up as infinitely many solutions or no solutions. The problem is x plus 4 minus 6x equals 6 minus 5x minus 2. We want to start off by simplifying both the left and right side. We can see that we have x and we have minus 6x. So we can simplify that to negative 5x plus 4. And on the right side, we see that we have a 6 and a negative 2, and you're able to combine like terms, so 6 minus 2 is going to give us 4. And we keep the negative 5x. Now we want to move the x's to one side. So we're going to add 5x to both sides in order to cancel it on one side. In this problem, we see that when we add 5x to both sides, both the x's become zeros, and we are left with positive 4 equals positive 4. When we are left with no variables and the equation is still true, 4 equals 4, that means there's infinitely many solutions. All values of x will make the equation true. Now we're going to look at an example that has no solutions. Negative 8x plus 6 plus 9x equals negative 17 plus x. First, we want to see if we can combine any like terms on both sides. So negative 8x plus 9x. That would leave us with 1x plus 6 on the left side equals negative 17 plus x. And now we want to move the x to one side, so we want to subtract x from both sides. Again, in this problem, like the previous one, when we subtract x from both sides, both the x's get canceled out on both sides. And we are left with 6 equals negative 17. But we know that 6 cannot equal negative 17, so that statement is false, therefore making it no solutions to the equation.